All right, we're going to start off with a review. The instructions here are perform the indicated operation. We're just going to do some combining functions. Let's take a look at the first problem. So the first one says do g times h. We know whenever we do multiplication, we want to use the box method now. I'm going to go ahead and steal the box that was covering it. Go ahead and split it up into 4 total boxes. The reason I did that is because g has 2 terms. So I need to be able to write n above one of the boxes plus 4 above the other. And then h has 2 terms as well. So I need to be able to write negative 3n and positive 2 for each of the boxes along the side. Now remember, we're going to multiply the big numbers, add the little numbers. If you don't see a big number, you get to assume it's 1. And if you don't see the little numbers, you also get to assume it's 1. Remember, the big numbers are called the coefficients. The little numbers are called the exponents. So multiplying the coefficients or the big numbers, we're going to get negative 3 times 1 is negative 3. Into the 1 plus, into the 1, I say plus because you're adding the little numbers. That's n squared. Technically, you're actually multiplying. So negative 3 times 4, that's going to give you, whoa, I almost wrote the wrong answer there. A little off while I'm making this video. That's actually negative 12. And into the 1, there is no variable there. So it's still just into the 1. Most people don't write that 1. Positive 2 times 1 is still positive 2. And then this is the only variable. So again, we're going to write n. It's technically into the 1, but most people don't write it. 4 is lined up with 2. When you multiply them, you get 8. So we're going to write the top one, negative 3n squared. Then we're going to write negative 12 in the next box, followed by the third box, positive 2n, and then plus 8 goes at the end. I want to point out that usually the diagonal boxes are like terms, and you can add them together. And in this case, they are. We'll start off by bringing this down. This is the only one that's squared. Negative 2n plus a 2n leaves you in the negative. That's negative 10n. And then positive 8 will go at the end. Let me slide this little bar out of the way. I don't know if you can see it, but it's in my way. All right, so normally that would be the answer, but they've given us some added stuff to do. They say now that you've found that, go ahead and plug in the 1. That's what that's saying. You're going to write negative 3, and anywhere you see the variable n, you're going to plug in that 1. You're going to use parentheses to do it. That way you keep the 10 and the 1 separated, the negative 3 and the 1 separated. Positive 8 here goes at the end. Remember, according to PEMDAS, we want to do the parentheses and the exponents first. 1 squared is still 1. 1 times negative 3, well, that's negative 3. Negative 10 times 1 is negative 10, and then the positive 8 goes at the end. Negative 3 and negative 10, that's negative 13 plus 8 gives us an answer of negative 5. All right, I'm going to clear this off, see what's behind box number 2. Box number 2 says, let's do subtraction this time. Let me slide this out of the way. So whenever I do these, I like to actually write f minus g. So that way I know what order to write each function in. What is function f? Well, according to this, f is 4x minus 3. Minus, because of the minus sign, you have to put the next function in parentheses. X cubed plus 2x. So remember, the negative is going to be distributed, and it's going to change all the symbols for the terms inside the parentheses. Function f is not going to change. It's going to stay the same. It's negative 3 here, it's negative 3 here, but when you send the negative into this one, everybody's symbol changes. So it says positive 2x, but now it's going to be negative 2x. All right, so now we're looking for like terms. This has the biggest exponent on it. You always want to put that one first. So x cubed. Do we have an x squared? Do we have an exponent of 2 anywhere? No, I don't see it. So then we go to an exponent of 1. That one has an exponent of 1. That one has an exponent of 1. 4x's minus 2x's. That's going to leave you with 2x's. One thing I like to do is kind of cross these off. It helps me keep track of the ones I've already used, but it's up to you how you do it. And this guy's one of a kind. He's the only one without a letter, so we're going to put that one at the end. That would normally be the answer, but this time they say, why don't you plug in 4? So again, anywhere you see a variable, we're going to plug in that 4. Instead of the x, we're going to plug in the 4. 4 cubed, 4 times 4 times 4. You can put it in your phone calculator. You're going to get 64. Boy, again, this is in my way. Let me slide it out. Here we go. 64 plus 2 times 4 is 8 minus 3. 64 plus 8, what is that? 72 minus 3. That means this one is equal to 69. Double check this. Make sure I added these and subtracted them right. Every once in a while I do a problem wrong. All right, there, that one's covered up. What's behind door number 3? Addition, that's easy, we can do that. H plus G. Well, what is H? It's 3x plus 3. Plus, now what is G? We don't need parentheses because it's a plus sign. Negative 4x plus 1. We're just going to simply look for the like terms. 3x and negative 4x. That's negative 1x. Cross them off. Helps keep track of what you've used. Positive 3 and positive 1. That makes positive 4. That would normally be the answer, but this time they say plug in 10. There's my parentheses for the 10. Negative 1 times 10 is negative 10 plus 4 gives me a total of negative 6. All right, last box for the review. What do we got? G divided by F. This one's pretty simple because you just put the G on top and you put the F on bottom. What would that look like? Well, G is 3a plus 2. F is 2a minus 4. Now in place of a, I wrote the wrong number. 3 parentheses. What number is it? Also a 3. Pretend that's a 2. Down here 2, there's my parentheses. Instead of a, we're going to plug 3. Minus 4. So on top, 3 times 3, I think that's 9, right? On the bottom, 2 times 3 is 6. Minus 4, and 9 plus 2 gives me 11. 6 minus 4 gives me 2. The answer to this is 11 halves. So that is combining functions and then substituting a number at the end. Got to check ahead and see where I'm going with this. All right, so we're going to talk about composing functions. I'm going to try to start it off easy, try to make it as simple as possible. We're going to look at tables. That's usually the way people think it makes the most sense. Now here's the deal with composing functions. You're going to work your way inside and out. There's 2 ways you're going to see it. F of G of 12. We're not just going to put a number inside of one of the functions. We're going to put the number inside the function and put the function inside the other function. That's kind of weird to think about. But don't sweat that yet. One thing I want to point out is this means F of G, and it means the same thing as when you write it like this. F of G. Or let's go back. This actually says F of G of 12. So we're plugging in an extra item, which is the same as saying F with the parentheses of G with the parentheses of 12. So if you see this little circle, it means the same thing as this with the parentheses. This is the way I personally like it, but it's up to you. Excuse me. So what are we trying to do? We're trying to work our way backwards. Inside out is what they call it. And that makes more sense down here. But you're going to start with the number, and you're going to go to that function or that table. This is your input. This is your x. So if I were to go to the g function, there it is right there. But I looked at the x value, which is actually right there. Where's 12? So I'm going to circle both of those. If I have an input of 12, I get out -8. So right now, this is my answer, but we're not done. So we still have f to do. Now we're looking for -8. So this g of 12 right here turned into a -8. Well, now we've got to go find -8 on the f table. Where's the f table? F is right there. But now we need to go to x and find -8. There it is. I'm going to circle both numbers. When I find -8, it's paired up with 16. And that's the answer. Wait, what? That's probably what you're saying. Let's do it again. So this is my x value, and I need to go to the g table. Here's the g table. But where does x equal 0? It equals it right here. Paired up with it is 1. So now this turned into f of 1. Well, let's go find 1 on the f table. Here's the f table. X is equal to 1, positive 1 right there. It's paired up with -2. That's my answer. Most people don't have it down yet by now, so let's keep doing it. If x is 12 and we go to the f table this time, so that means we're using this one and x is 12 right there, then the answer is -24. So now it's turned into g of -24. All right, let's go find -24 on the g table. G's right here. Where is x -24? Looks like our answer is 19. All right, let's try it again. I'll pause 1 second. Go find 1 on the f table. What's it paired up with? One on the f table. Here's the f table. X is equal to 1 right there. So this now became h of -1. All right, I'll pause again. Go find -1 and see what it's paired up with on the h table. There's the h table. -1 is paired up with 0.5. Now we've done everything it's asked. That's the answer. Go find 3 on the f table. What's it paired up with? Three on the f table. There's f. There's 3. Wow, it's still 3. 3 and 3. All right, so this turned into h of 3 now. Go find 3 on the h table. What's it paired up with? There's the h table. X is equal to 3 there. Looks like our answer is 8. All right, let's do another. Go find 0 on the h table. What's it paired up with? There's the H table. Remember, we're looking the X value, we want it to be 0. What's it paired up with? 1. So now this H of 0 is actually 1, but we still have F to do. That's why it's out in front. Go see what 1's paired up with on the F table. Going to the other table, looking at X, we need a value of 1. It's paired up with -1. We've done everything they asked. That's the answer. It's the final answer. All right, so I know this is kind of long. You're probably going to want to write all the highlighted stuff in your notes. Here's the way you want to think about this with equations now. We've got this equation g of x is equal to x cubed plus 2. We want to find g of 3. Remember, that just means anywhere there's an x, we just want to plug in 3. So I'd change this to g of 3 is equal to, and we're using parentheses, 3 cubed plus 2. So there's no more x's. We're just plugging in 3's. We really care about this side. So what is 3 cubed? 3 times 3 is 9 times 3. I think it's 27. We still have the plus 2. 27 plus 2. You know how we went and found what the number was paired up with in the first table? We're doing the same thing here. We're plugging in a number to the first equation to see what we get. We got 29. Then in the tables, we took our new number and we went to the other table to see what the new number was paired up with. Well, that's what we're going to do over here. So now here's the second function. F of x is equal to 3x minus 1. Now we're going to plug in that new number, the 29 that was the answer to g of x, or g of 3, I should say. Now we're going to make that the input and call it f of 29. So if we plug in the 29 using parentheses, oh boy, oh boy, oh boy. I got to ask my phone. I don't even know. 3 times 29.
It's 87.
87 is what it looks like. Sometimes you got to cheat. And 87 minus 1. Oh, I should have known it was written down there. It's equal to 86. So you're given two functions. This is how this is going to play out. They're going to say f of g of 3. You're going to plug 3 into the g function, see what you get. We got 29. Then you're going to take that 29 and you're going to plug it into the f function, see what you get. We got 86. Here's another way to think about it. Take 3, plug it into g. You're going to get 29. Now take 29, plug it into the f function, see what you get. You're going to get 86. And that's your final answer. Hopefully that made some sense. All right, let's practice a couple. Let me cover some of these up. Guess I'll do these two. Notice this one's a little bit longer. So this says do f of g of -3. Let's plug -3 into g. What is the g function? The g function was 3x, but they want us to plug in -3. What's 3 times -3? Well, that's equal to -9. Well, now we want to take this -9. This is technically f of -9. We're going to plug it into the f function. Well, what was the f function? Looking up at the top, I'm seeing it right here. It's 2x minus 1. But we don't want the x. We want to plug in -9, the answer that we got up here. 2 times -9 is -18 minus 1. Hey, that gives me -19. And I've done everything they asked. And so that's my answer. All right, let's do it again. Now it's going to get really, really hard. We're going to plug 2 into h. Well, what's h? H is x squared plus 1. Instead of the x squared, we want to plug in, what was it? 2. So 2 squared plus 1. Well, 2 squared, that's 4, and 4 plus 1, isn't that 5? Okay, great. So now we've got f of g, this h of 2 turned into a 5. Well, now we need to take the 5, go plug it into g. What was g? Oh yeah, 3x. Well, let's use the parentheses, and instead of x, let's plug in the previous 5. Isn't 3 times 5 15? All right, so now this became f of 15. Well, what was f? 2x minus 1. Okay. Let's replace x with the previous answer, which was 15. 2 times 15, that's 30. And 30 minus 1, 29. We've used all 3 functions, h and then g and then f. And so that's our final answer. It's equal to 29. All right, go try out part A. See how you do.